right, so what we're gonna do today is in your packet that I handed you, we are gonna go through a couple select questions. What I want to make sure that I do is give you at least one of each question, and then your packet contains extra that if you want to go back through and do, you certainly can. Right on your Google Doc, do you see where it says Module 1 Review Solutions right here? All you'd have to do is click on that file, and that's all the answers written out for you if you want to go back and do any of those questions. So today we are going to go over these. So 6 through 8, 12, 13, 14A, 15, and 17. Your homework assignment is actually, I changed it, not due until Friday at 7 a.m. And those are all just the Delta Math review questions. Okay, so you have a couple days to kind of work through those and make sure that you are good to go. Next thing you probably want to look at is on this document also, do you see this bulleted list? Those are your test questions. No surprises. I want you to feel prepared and to be able to do a good job on that test. If you can do all those things, then you will be prepared. Okay, so those are the topics that you want to focus and concentrate your efforts on. So let's jump in and start going through some of those items together. So can you please turn to question number 6? That's where we're going to pick up. And again, I'm going to skip over some of these. It doesn't mean they're not good questions. I just want to concentrate on one of each topic, and then I will leave you the extra to practice. Bless you. All right, to solve the following by factoring in the quadratic formula. So regardless, what does this need to be equal to first? 0. So I'm going to just squeeze that right in here. And we're going to go 5x squared minus 19x minus 4 equals 0. Okay, so method number 1 is AC. So over here, this is factoring by AC method. And let's start. So 5 times -4 would give me -20. And then what numbers multiplied in -20 that add in the middle to -19? Yep. Perfect. -20, +1. Awesome. Now you're going to put those back in. So I'm going to have a 5x squared minus 20x plus 1x and minus 4. And again, you guys know what to do. So I'm going to split this right down the middle. And I'm going to factor by grouping. So I take out a 5x, and we are left with x minus 4. Go over to the other side. What do I have to take out of this side? A 1, and then I'm left with x minus 4. Okay, so I have the factor 5x plus 1 on the left, and x minus 4 on the right. And then you T-chart, solve, done. Okay, so my first answer on the left-hand side, I do 5x plus 1 equals 0. So I'm going to go -1 minus 1. So 5x is equal to -1, bless you. And divide by 5. And there's your first answer. So x is equal to -1/5. The other answer is the really fast one. So what do I do with the sign? Flip it. X equals 4. Okay. So that's a solve by factoring question. You definitely want to be able to do that. And I believe that most of you already are good with that. So now I'm going to go on to the other side, and now we're going to do the quadratic formula. Quadratic formula is x is equal to -b plus and minus the square root of b squared minus 4ac all over 2a. And this is going to yield the same exact answers as we obtained on the left, just a different way to do it. So I'm going to go x is equal to negative 19, which just becomes 19, good, plus and minus the square root of parentheses, negative 19 squared, minus 4 times 5 times negative 4, all divided by 2 times 5, which is just 10. Okay, get those calculators out. And your value underneath the square root is equivalent to 441, if I'm not mistaken. Yes. And then all over 10. So we're going to keep going. Can you evenly take the square root of 441? Yes, 21. So I have 19 plus and minus 21 over 10. And because this is going to produce nice rational answers, you are expected to continue with this one. So all I do is I go 19 plus 21 over 10. So that is 40 divided by 10, which is equal to 4. And does that match our first answer? Yep, sure does. And then the second one is going to be 19 minus 21, which is negative 2 divided by 10. When you reduce that, also gives you the second answer, which is negative 1. Okay, so just my way of getting you to practice both methods. How do we feel with number 6? Wonderful. So number 7, we're going to determine whether or not x plus 1 is a factor using long division. So to determine if something is a factor, we are going to look at whether or not we have a remainder. So if I do long division, I'm going to take x plus 1, and we're going to divide, and I have 2x squared plus 5x plus 3. All right, on top of the house, what do I need to multiply x by to produce the term 2x squared? 2x, good. That goes right here. 2x times x is 2x squared. And then 2x times 1 is 2x. And then you subtract. All right, so I'm going to have a 3x plus 3 and do it one more time. So what do we need to multiply by to make it say 3x? Good. Distribute it. I get 3x plus 3. And does this have a remainder? Nope. So no remainder. So therefore, can we conclude that x plus 1 is a factor? Yes. As long as you don't have a remainder, you can always make that conclusion. So I'm going to say yes. X plus 1 is a factor. Your reasoning, remainder of 0 or no remainder. Okay, nice, quick, and easy. So we also did that using synthetic division. So to do synthetic division, I am going to take my binomial right here, x minus 5. And what do I do with the negative 5? Switch it. Yep, make it a positive. And then I'm going to do the same exact thing with the division and assess whether or not I have a remainder. So I have a 3, a negative 22, and a 35. So my first value comes straight down. And 3 times 5 is 15. Addition gives me a negative 7. You're going to do it again. So negative 7 times 5 is, yeah, negative 35. And does this also work? Yes. So you're going to make the same conclusion as before. Again, if you get any particular remainder, you just say no. I'm going to say yes. X minus 5 is a factor. My reasoning, I have no remainder or a remainder of 0. I'm going to just say remainder equals 0. Okay. Questions on any problems from that page? Okay. Excuse me. 9, I'm going to skip. We did that yesterday. That's factor and cancel. Number 10, I'm going to skip. That is an equation where you're going to find the common denominator. Again, you are more than welcome to go back and do those if you'd like. You know where to find the answers. Similarly, number 11, what would 11 be? Common denominator. We did it yesterday. I'm skipping it. We did not do this yesterday, so let's do one of these. Solve the system of equations with 3 variables. Now you got to be able to do this by hand. Yes, you have one of these on Friday. What should I immediately do with these 3 equations before I do the algebra? Calculator. All right, so let's get those out. You're going to go right into your calculator and you're going to type this into the matrix. And I believe that mine is still in there just for the sake of time. Okay, so you're going to hit second matrix. You're going to go over to edit and hit enter. And you are going to type all the coefficients into your matrix. So you're going to type them all in. Remember that in the instance that something is missing, you would include a 0 in that respective position. Once everything is typed, I'm going to quit back to my home screen. And then I'm going to do a matrix function with this. So I'm going to hit second matrix. I'm going to scroll over to math. And I'm going to scroll up to choice B, which stands for reduced row echelon form. Hit enter. I'm going to grab matrix A by hitting second matrix. Enter on A, and then enter. So respectively in the last column, my answers should come back as -2, 4, and -3. Did everyone get that okay? Perfect. So I'm going to write those right at the top of my problem so that I can check back at each little step to make sure we're in good shape. -2, 4, and -3 is what we're looking at. All right, so -2, 4, and -3. Okay, so let's start doing the algebraic portion of this. I need to put 2 equations together and I need to eliminate something. So let's go equations 1 and 2. What would you like to eliminate? The y? Absolutely. So this is a 3. So how about we multiply this by -3? So let's do equations 1 and 2. And I agree. I think that's probably easiest. Let's eliminate the y. And I'm going to try to do some of this work up on the top so that we don't have to keep writing it all. So we're going to take this equation and we're going to multiply it by -3. So I'll just do this. My top equation stays the same. So -5x plus 3y plus 6z equals 4. And my second equation becomes a -9x minus a 3y minus a 15z equal to 15. Say that again. Oh, thank you. Yep, because I'm seeing the negative there. Thank you. Add straight down. And what do we get from this? So I have 4x, your y's have canceled. And then we have minus 9z equal to 19. Okay, box it please. And we're going to come back to this. Our plan has to be the same. So now the next equations to put together, actually the easiest would probably be 2 and 3. What do you guys think? Yeah, let's do that. So now in orange, I'm going to do 2 and 3 together. This has a 2y, which means what could I multiply this one by? -2. I'm going to just show it over here again, and then we'll do it beneath. So I'm going to go equation 2 and 3. So 2 and 3. My plan must be the same. So I am going to eliminate the y. Okay, trying to cut down on the amount of work here. -2 times -3x would be 6x. And then I have minus 2y minus 10z. Be careful with z's, please. And that equals 10. I'm going to make sure your z's don't look like 2's accidentally. Other equation is exactly the same. So -4x plus 2y plus 1z is equal to 13. And you're going to add these straight down. I have a 2x minus 9z equal to 23. Box it. And now we continue. You've reduced this down to a 2-variable system, which you can solve with your elimination. So now I'm going to continue and see what you guys prefer on this. Isn't there a variable that would go away nicely here? Which one, x or z? Z. So let's now eliminate our z. This is personal preference. If you want, you don't have to do anything with these, and because the signs on the z are the same, you could just subtract them straight down. That is option number 1. Option number 2, if you think you're going to make an error with subtraction, you can take one of these equations and multiply it by a -1. What do we prefer? Multiply by -1 or subtract? Okay, yep, I agree. So take this equation, multiply it by -1. So I would get -4x plus the 9z equal to -19. And then this one would be 2x minus the 9z equal to 23. Typically, students make less mistakes when you're doing the addition versus the subtraction. So I don't think that adds too much work to do that. I am left with a -2x equal to 4. So x is equal to -2. Does that check? It does. Now let's find our next variable. You cannot go back to the original. You have to go back to your boxes. So we need to find the z. The next step is to find z using either of those 2 equations. So let's go 4 times the -2 minus 9z equal to 19. So I have -8 minus 9z equal to 19 plus 8 plus 8. I have -9z equal to 27, divide by -9, and z is equal to, does that match? Yes, it does. that leaves us with our final step. What variable are we missing? The y. Yep. So lastly, I find the y. I need to go back up to the originals at this point, but I can choose any of the three. What do you guys prefer? 2? Okay. So I'm going to go negative 3x. So negative 3 times negative 2 plus y plus 5 times negative 3 equal to negative 5. All right, so I have here 6 plus 5 minus 15 is equal to negative 5. So I have y minus 9 equal to negative 5. Add your 9, and you are done. So y is equal to 4. Does it work? Yes, it does. How do we feel about? Good. And again, use your calculators because obviously you can check that. So number 13, I'm going to ask you guys to decide. Do you need number 13 or is that pretty fresh in your head still? That's what I figured. So I'm going to skip 13. Obviously, you can, of course, go back to it. The next problem I want to do is 14a. So 14a says to, and this one cross off forever. Don't ever go back to that one. I don't like how I wrote that. I'm going to change it. So we'll put something new there instead. So for question 14a, this is in factored form. So this is already in factored form. So to find the zeros, I simply t-chart. And then we're going to find the degree here as well. Okay, so x cubed. That means that x equals 0. And multiplicity means how many times? So what would, yep, 3. The next one, I would go x minus 4 equals 0. So x would be equal to 4. And how many times does that occur? Twice. But if you look very closely, this next binomial is x squared minus 1, meaning that that is difference of 2 squares. So we have to actually factor this. I'm going to do it down here. So this is, excuse me, x plus 1, x minus 1, which means that this is x equals negative 1. Only occurs once, so multiplicity of 1. And this one is x equals 1, multiplicity of 1. And then my last one, this would be x minus 5 equals 0 if you want to show it. So therefore, x would be equal to 5, multiplicity of 1. The next thing I asked you is to state the degree of a polynomial. So the degree in this case is found by adding all of those multiplicities. So the degree, your procedure is to add the multiplicities. And I'm writing this on here just in case you look back and want the work. So I would do multiplicity of 3, 2, 1, a 1, and a 1. So this would be a degree 8 polynomial. We don't have a name for it. You just call it degree 8. Okay, how was that one? Okay. Now, where I crossed off B, could you please write this instead? G of x equals, it'll be really short, 3x to the 4th plus 2x squared plus 10. is this still in factor form? No, what is this form called? Standard form. All I would like you to tell me is just the degree of this polynomial or function. What would my degree be this time? 4, I heard it, good. How do you find the degree when you're in standard form? What do you look at? Yep, the leading term, which has the largest exponent. Yep, so just like that. So this degree is based off of your leading term. You do not add. I wanted you to have those examples kind of side by side so you can see the difference. Okay, is that one okay? All right, 2 more. 15 I want to do. This was not a concept that you had any difficulty with, but just to review it. So this is one of those word problems in which people are working together. So you're going to express these as weights and find common denominators. So it says it takes Juan 4 hours to deliver all the papers on his paper route. So he has the 1 paper route, and he is going to accomplish his route in 4 hours. When his dad helps him, so he's working together with his dad, the 2 of them together can deliver all the papers in 2 hours and 30 minutes. So together, they have the 1 paper route, and they're going to accomplish it in 2.5 hours. How long is it going to take Ron's dad by himself? So how do I write him in the middle here? 1 over x. Perfect. This is the type of question that requires a common denominator. So what can I use for 4 and 2.5? Multiply them together in your calculator. What do you get? 10. And then you also need the x. So our common denominators are all 10x. That is your least common denominator. Okay. So my first fraction, what do I need to multiply the 4 by to make it say 10x? 2.5x. Good. I have 2.5x here. And move to the next one. Multiply it by 10. I move to the next one and I multiply it by 4x. Because you have an equal sign, you are permitted to omit the denominator. So that's gone. And I solve 2.5x plus 10 equal to 4x. Subtract 2.5x over, and I get 10 is equal to 1.5x. And could someone please type that in the calculator and we can round this to the nearest, let's go nearest 10. So how many hours is it going to take his dad if he works by himself? 6.7, thank you. So 6.7 total hours. Okay. So that is one of those word problems in which, again, you have people that are working together to accomplish that one task. Questions on that one? Okay. 16, I'm going to skip. It's a 3-variable system. We did one today. And overall, I think you're all fairly confident with that. So I want to do one last question, and that is number 17. This has something that hasn't come up in a while, so that's why I picked it. So it says to solve the following quadratic equation in simplest form. So it doesn't specify that you have to factor it, which means it might not factor. So a method that works for all quadratic equations, quadratic formula. Yep. So quadratic formula. I'm going to do this quick. So it's already equal to 0. So your formula goes, x is equal to negative b plus and minus the square root of b squared minus 4 times a times the c, all over 2 times a, which in our case would be 4. Now I keep going, I get the value underneath my square root. And this is what I'm curious if we remember or not. What do you get underneath your square root? Say it again. How much was it? Negative 28. Thank you. You're right. All over 4. Now, we discussed something that pertains to when you get a negative under a square root. It's an I. So I continue this and I go x is equal to 2 plus or minus 28 simplifies to 4 and 7. And then the square root of negative 1 is where that I is going to come from in a moment. So over 4. So nice and slow. I have x is equal to 2 plus or minus. The square root of 4 is rational, it becomes 2. Your 7 stays inside. And the square root of negative 1 becomes the I. Over 4. Are you done? Good. These 3 values are all divisible by 2. Therefore, you must reduce this. So my final answer, divide by 2 is 1. Divide by 2 is 1i. The radical 7 remains attached at the top. And 4 divided by 2 is, so this represents a quadratic with imaginary roots. You guys remember the I? You're kind of coming back to a little bit? Okay, wonderful. So I'm going to stop there for today. Here's what you are responsible for. So you have, again, homework that's on Delta Math. It is not due until Friday morning. Work on those at your own pace. If you need something reset, yes, I'm happy to do that. When you come in tomorrow, we will go through, we're going to start right here on this review sheet, which is just more practice of those topics that are kind of heavily covered. Okay. Questions on anything?